Color control replacement imaging systems include all of the necessary components: toner, drum, wiper blade, PCR, doctor blade, developer roller, toner adder roller, plus the chip. The reason color control systems can deliver consistent OEM comparable performance every time is not due to new components. Clone cartridges are built with a collection of all new components, but that does not make them any more dependable than a cartridge with cleaned, reused components and only new toner, drum, wiper blade, and chip. The problem is components that are designed and manufactured in isolation from one another. To achieve the highest quality, components must be engineered and manufactured as an integrated system. That's how Canon and HP do it, and that's exactly how we do it for color control systems. History proves that mixing new components with cleaned and reused components is not the answer. It is impossible to consistently clean components to the tolerances needed to achieve high-quality performance every time. All of the components must work together. Even the tiniest variation in one or more of the components can quickly add up to poor quality. The first step in developing a system of components was to understand how each one functions in the system. We needed to understand exactly how the OEM created their imaging system. What are the electrical parameters? How does each component respond to the printer and to the other components? What happens as the cartridge passes through its life cycle? The questions go on and on. It took years of extensive research to learn all of the answers. Next, we needed to fully research the patents that protect the technology. Respect for intellectual property rights is very important to us. So we wanted to know what roadblocks we may encounter during our design process. With a thorough understanding of the technical and legal issues, we were ready to design an integrated system of components, with each component qualified to accommodate and overcome any limitations of the other components within the system. For example, the toner, developer roller, doctor blade, and toner adder roller work together to charge the toner. It starts with the toner and toner adder roller, but our design team knows that there are patents covering the electrical conductivity of the foam of the adder roller. The design of the replacement roller has to take this into account. A slight change can be made to the toner, but what if the change makes the toner more vulnerable to shearing? No problem, we'll just adjust the pressure between the doctor blade and the developer roller. With less pressure, the doctor blade and developer roller are not quite as effective in the final stages of the charging process, so it's back to the toner and toner adder roller for some fine-tuning. It's a delicate balancing act, and it is impossible to achieve when developing components in isolation. Toner charging is just one example. The balancing act is very similar and just as difficult for every component at every step of the imaging process. Thanks to the hard work and sharp minds of our legal and engineering teams, we have succeeded in finding that balance, and color control is a reality. With the system developed, it was time for manufacturing. We set very strict tolerances for each component. That's why we chose to manufacture them at our world headquarters in Sanford, North Carolina. Our in-house production ensured that every component would meet or exceed our high-quality control standards. Static Control's dedication to excellence and commitment to quality is why color control is different from anything else available to the aftermarket.